Radioactive decay is really similar to our law of exponential change. The one thing now that is going to happen every single time with decay is that k is going to be less than 0. Remember, k is some constant value, and k is going to be less than 0. So I know if you're looking at this looks weird, okay? But think about what's going on. I need k to be negative. So if k is greater than 0, I have a negative value here. Okay? If k is less than 0, I have a negative value here. So it looks funny, but it's true. All right? So half-life then. Find half-life. This is the amount of time required for half of a radioactive substance to decay. So if the half-life of equation, find the half-life of a radioactive substance using the decay equation, y equals y0 e to the negative kt, and show that the half-life only depends on k. Here's the thing. If this is my starting equation right here, then y0, just like in our previous example, is an initial amount. And so if my initial amount is going to be half of that, then the equation that I'm going to look for is that 1/2 y0 is equal to y0 times e to the negative kt. That's the setup on this. And so if I'm going to try and solve this guy down, if you'll notice right off the bat, I can divide both sides. I can divide both sides by y0. Divide this by y0. Divide this by y0. Okay? And when I do that, what I end up with is 1/2 equals e to the negative kt. Okay? Not bad, not bad. But I've got this whole exponential issue going on. So one of the cool tricks that we can use is you can take a natural log of both sides. And when I take a natural log of e, it undoes itself and leaves me with just kt. When I take the natural log of 1/2, I get natural log of 1/2. So natural log of 1/2 is equal negative kt. Okay? That's not too bad. So remember, we want to show that half-life depends only on k. All right? So what we should try and do then is get this equation to say like t equals or something along those lines. So if I'm going to do that, all I'm going to do to kind of get where I'm going to finish this guy is just divide both sides by negative k. So negative natural log 1/2 divided by k equals t. Okay, well, that looks cool and all, but there's one more step, and that is this. If I am looking at 1/2, that's the same thing as 2 to the negative 1. And if I have a logarithm where I have 2 to the negative 1, that's the same thing as taking that negative 1 and multiplying the logarithm. So to finish this whole problem, I would do that by saying that I've got negative this guy, negative 1 times the natural log of 2 all over k equals t. And that's where we're at. So simplify this up and you end up with that the natural log of 2 divided by whatever our constant is for our problem will tell us the amount of time. And once you solve out this differential equation and you look at it, k is the only thing that can have an impact on half-life. And once we know what that k value is, we can determine the amount of time it'll take. And that's what this problem is showing us. It's really cool. And it can be a little bit confusing at first. But the key thing here is that the initial value doesn't matter because it divides out on the very first step.